Two geometrical figures are said to be congruent if they have the same shape and if they have the same size. So when are two circles said to be congruent? Well, all the circles have the same shape always because all the circles are round and circular. So the condition required for two circles to be congruent is that they should be of the same size. Now when will two circles be of the same size? When they have equal radius. So as we can see, these two circles with center A and center B, they have equal radius equal to 3 units. So this has radius 3 units, this has radius 3 units. So we can say that these two circles are of the same size. Hence, these two circles are congruent circles. So two circles are said to be congruent if they have equal radius. If I draw another circle with radius 3 units and center C say, then even this circle will be congruent to each of these two circles. So two or more circles are said to be congruent if they have equal radius. So let me tell you a story now. There was a circular cricket field and there was this person called Mr. James. He wanted to convert this cricket field into a football field. Now football fields are typically rectangular in shape. But Mr. James wanted a special kind of a football field which would be square in shape. So he wanted a football field of maximum possible size to be constructed from this circular cricket field. All he knew was the center of this circular cricket field. So now what he did is he started from here, made a straight line which is the chord of this circle. Then he turned 90 degrees and made another chord from there. Again he turned 90 degrees, made another chord, and again he did the same. So this is what he had obtained. We can clearly see that this is not a square. This is a rectangle. So he started all over again. He started from here, made a chord, turned 90 degrees, made another chord. Again, he made this chord at 90 degrees and repeated the process. And this is what he gets. Clearly, even this is not a square field. So Mr. James soon realized that it would take a lot of time and effort if he tries to do it by trial and error method. So is there any way in which he can do it in one go? Yes, he can using maths and circles. Let us see how he can do it. Now this is a circle and this is a chord of length 7 centimeter. What we do is from the end of this chord to the center, we draw a line. And from the other end of the chord to the center, we draw yet another line. These two lines make this angle with center at the vertex. So these two lines and this vertex, which is the center, make this angle. This angle is called the angle subtended by this chord at the center. So this is the angle subtended by this chord at the center. Now let us take another chord of the same length, that is 7 centimeter. This is the angle subtended by this chord and this is the angle subtended by this chord. If this angle is theta, then this angle, will it also be theta? That is, will the angle subtended by equal chords at the center of the circle be equal? Well, yes. The angles subtended by equal chords at the center of the circle will always be equal. So let us prove this. Equal chords of a circle make equal angles at the center. So we have chords SP and RQ of this circle. SP is equal to RQ. What we need to prove is angle SAP is equal to angle RAQ. So let us try and see if we can do that. So the theorem is equal chords make equal angles at the center. It is given that chord SP is equal to chord RQ. Now, to make angles at the center, we need to join these. So, we join AS, AR, AQ and AP. We join all this. So, we need to prove that this angle is equal to this angle, because chord SP subtends this angle at the center and chord QR subtends this angle at the center. So we need to prove angle PAS equal to angle QAR. This is what we need to prove. Now how can we prove this? Well, we can see two triangles here, triangle PAS and triangle QAR. If in some manner we can prove these two triangles to be congruent, because we know a lot of axioms of congruency of triangles. So if we can prove these two triangles to be congruent, then we can say that these two angles are also equal, because corresponding parts of congruent triangles are equal. So in circles, in most of the proofs, what we do is we try to find relevant triangles and try to prove them to be congruent by some or the other axiom of congruency. So we see triangles PAS and QAR here. So in triangles PAS and QAR, let us see what all can we find to be equal. So in triangles PAS and QAR, firstly, AS is equal to AR. Why is AS equal to AR? Because both are the radii of the circle. AS is a radius, A is the center, S is a point on the circle, so AS is the radius. Similarly, R is a point on the circle, so even AR is a radius of the circle. So AS is equal to AR. Now, AP is equal to AQ. Again, these two are the radii of this circle. So AP is equal to AQ. Also, SP is equal to RQ. This is given to us that these two chords are equal. So we have SP is equal to RQ. It is given. So we see that in these two triangles, triangles PAS and triangle QAR, we have side, side, side. Three sides is equal. So we can say that triangle PAS is congruent to triangle QAR, that is triangle PAS is congruent to triangle QAR by SSS congruency. Because we know that if three sides of two triangles are equal, then the two triangles are congruent. So we can see that the three sides of these two triangles are equal. So these two triangles will be congruent. Hence, triangle PAS is congruent to triangle QAR. So these two triangles are congruent. Now, this angle will be equal to this angle because the corresponding parts of congruent triangles are equal. So we have angle PAS equal to angle QAR because corresponding parts of congruent triangles are always equal. Hence, we have proved this, that angle PAS is equal to angle QAR. So we have seen that equal chords of a circle make equal angles at the center. Now what if we have congruent circles? So we have already proved this. But what if we have these two circles which are congruent circles and the chords are equal? So chord of this circle SP is equal to chord of this circle which is RQ. What can we say about the angle subtended at the center by these chords? That is angle PAS and angle RBQ. Well, even these will be equal. So, equal chords of a circle or congruent circles make equal angles at the center. So, whenever we have equal chords, whether they are in the same circle or they are in the congruent circles, they always subtend equal angles at the center. Now, what is the converse of this theorem? Well, the converse of this theorem is that if the angles subtended by two chords of a circle at the center are equal, then the chords will also be equal. So, we see that SP and RQ are any two chords. They subtend angles SAP and RAQ at the center. It is given that SAP is equal to angle RAQ and we need to prove that chord SP is equal to chord RQ. So let us see how we can do that. So if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So SP and RQ are the chords. Now, the angles subtended by them are angle PAS and angle QAR. So it is given that these two are equal. What we need to prove is that SP is equal to RQ. So let us see how we can prove this. Now once again, we take help of the congruency of triangles. In this case also, we can see two triangles, triangle PAS and triangle QAR. Let us see if we can prove them to be congruent. So in triangles PAS and triangle QAR, first thing we see is that AS equal to AR because A is the center of the circle, S is a point on the circle. So AS is the radius of this circle. Also, AR is the radius of this circle. So AS and AR both are radii of this circle, hence they are equal. Now it is given to us that angle PAS is equal to angle QAR. Angle PAS is equal to angle QAR. This is already given. Also, AP is equal to AQ because once again both are radii of the same circle. AP is equal to AQ. So in these two triangles we have this side which is equal, this angle which is equal, and this side which is equal. So these two sides are equal. These two pairs of corresponding sides are equal and an included angle is equal. So we can say that these two triangles are congruent by SAS axiom of congruency. So triangle PAS is congruent to triangle QAR by SAS congruency. Now, since these two triangles are congruent, their corresponding parts will be equal. So PS and QR will be equal because these are the corresponding sides of congruent triangles. So SP is equal to RQ because these are corresponding parts of congruent triangles. So we started off with equal angles PAS and QAR, and then we proved that the chords corresponding to these angles are also equal. So we see that if the angles subtended at the center are equal, then the chords are also equal. So let us come back to the problem of Mr. James. So he has learned this theorem. Now, how can he convert this circular cricket field into a square field? He knows the center of this field. So what he does is, he draws a straight line passing through the center of this field in this manner. Now this line is the diameter of this circular field. So it divides the circular field into two equal parts. Next, what he does is, again, he draws a straight line passing through the center of this field, which is also a diameter of this circle, but at an angle of 90 degrees to this. So this angle is 90 degree. Now, even this angle will be 90 degree. This angle will also be 90 degree. This angle will also be 90 degree because these two lines are perpendicular. Now, since all the angles are equal, what can we say if angles at the center are equal? Well, if angles at the center are equal, then the corresponding chords will also be equal. So, now using these endpoints, joining these endpoints, he gets all four sides as equal and he gets his square. So using this, he gets a square field. So we can see how different problems can be solved using mathematics and how mathematics comes to our rescue in different real life applications. So we have seen that in same or congruent circles, if chords are equal, then the angles at the center will be equal and vice versa. If the angles at the center are equal, then the corresponding chords will be equal. So, since these chords are equal, the angles at the center will be equal. If the angles at the center are equal, then the corresponding chords will also be equal. This is a very important theorem of geometry.